Have you ever wondered where calculus came from? The average AP Calculus student spends about 80 minutes of calculus a day, including class time. That is about 12,800 minutes of calculus throughout the year, a total of 213 hours. But only a few even stop to question where all the theorems and laws come from, and even less care to find out. So, for that reason, I present to you a brief history of calculus. Math has been around for longer than any of us can imagine, and calculus has its roots in the early forms of math that belonged to the Greeks. Although they avoided infinite processes, the Greeks had several formulas for simple shapes such as triangles or squares, and thanks to Archimedes, an estimation of pi as between 3.1408 and 3.1428. Euclid, a Greek mathematician, used these known laws to figure out areas by the method of exhaustion. Similarly to how we find areas of curves today, he inscribed shapes of known area into shapes of unknown area until all the space was covered up, and used this to find the area. After the Greeks came several mathematicians that hinted at calculus. In the late 1500s, Johannes Kepler bought a barrel of wine for his second wedding, and the merchant who sold it to him had a method of calculating the volume of the barrel that angered Kepler. The merchant inserted a stick through the tap hole of the barrel to the opposite edge of the lid of the barrel, and the length of the stick determined the price. Kepler was outraged because a narrow barrel with a small volume could have the same length and therefore the same price as a much larger one. This incident then inspired Kepler to study and write a book about calculating areas of volumes. He pictured the wine in a full barrel as made up of thin layers, each as a cylinder. He realized that the more cylinders he had, the more accurate this measurement would be. His first book, which has a name that translates to New Solid Geometry of Wine Barrels, was his main contribution to the development of integral calculus, but he also worked towards maximizing the volume of the barrels, even though he did not think in terms of graphs. After Kepler came Pierre de Fermat, a mathematician who anticipated calculus when he developed a method for determining maxima, minima, and tangents to various curves. This method was essentially equivalent to differentiation. He found the maximum and minimum values of curves by considering what we write as f of x plus e minus f of x all over e, dividing as if e were non-zero, and then dropping e as if it were zero. Fermat was also one of the first to notice, though only in special cases, a link between tangent problems and area problems. And now, finally, come Newton and Leibniz. Before them, the only person who had come close to the fundamental theorem of calculus was Isaac Barrow, who had geometric statements of both versions of it, but did not exploit this understanding. Other than discovering the generalized binomial theorem, contributing to the theory of finite differences, being one of the first to use fractional exponents, among many other achievements, Newton was the first to discover the inverse relationship between a derivative and an integral. As a physicist, Newton created the laws of gravitation and motion, and was faced with the challenge of describing the speed of an object as it falls. However, he quickly realized that no math at the time could describe an object whose speed is increasing at every split second. Therefore, he went on to discover derivatives for the purpose of graphing a falling object. This was how he began working on differential calculus, or as he called it, the method of fluxion. He called the instantaneous rate of change at a particular point the fluxion, and the changing values of x and y the fluents. On another occasion, a colleague of his asked him, "Why are the orbits of the planets in an ellipse?" To which he answered that he would get back to him. For this, he went on to discover integration, or as he called it, the method of fluids, which he recognized as the opposite of the method of fluxion. So when he met with his colleague again, he explained that ellipses are sections of cones, and with his new math, calculus, he could explain how these sections behaved. Other than this, Newton also worked out the chain rule, showed how to take derivatives of products and quotients, intuitively explained the fundamental theorem of calculus, worked out a table of antiderivatives by using integration and substitution along with his newly invented binomial series, found maximums and minimums by setting the derivative equal to zero and solving, and after his initial use of infinitesimals was the first to use something that approached the idea of a limit as we know it today. Gottfried Wilhelm Leibniz was born into a pious Lutheran family near the end of the 30 Years' War, which had laid Germany in ruins. As a child, he went to school but was largely self-taught in the library of his father, who had died in 1952. He was concerned with the proportion between a circle and a circumscribed square. In 1684, he published his book, New Method for the Greatest and the Least, which was an exposition of his differential calculus. For Leibniz, calculus was more about analysis of change in graphs. He based his approach to derivatives on infinitesimal changes in x and y, which he denoted dx and dy, and defined the derivative as the ratio of dy and dx, dy dx. He did not develop an approach to limits as did Newton, but he did work out the derivative of power functions as well as the product rule and quotient rule, writing everything in terms of differentials rather than derivatives. He observed that dv is positive when the velocity is increasing, and analogously for decreasing, hence that local extrema occur only when dv equals 0. He viewed integrals as a type of sum and differentials as a type of difference, and hence integrals and differentials had an inverse relation. There is a long-standing controversy as to who invented calculus. Europe first heard about calculus from Leibniz in 1684, not from Newton, who published nothing until 1693. Unlike Leibniz, Newton was always hesitant to publish his ideas in fear that his colleagues would ridicule him, so he had no proof to his claim that he invented calculus first. In 1705, Leibniz publicly accused Newton of plagiarizing his research, and claimed that he had discovered infinitesimal calculus several years before the publication of Newton's Principia. In 1712, the Royal Society appointed a committee to investigate the matter. However, Newton was the president of this society, so he got members to oversee the investigation. Not surprisingly, the committee gave Newton credit for the first discovery and gave Leibniz credit for the first publication of calculus. Later, the Royal Society accused Leibniz of plagiarism, from which he never recovered. After Leibniz and Newton, there were many other mathematicians who changed calculus to the way we know it today. One of these was Euler. Euler's life was unbelievable. He was a man that had 13 children and went blind for the last 17 years of his life. Yet he still managed to publish on average about 800 pages of research a year. Euler gave us symbols for pi and e. There was also Joseph Louis Lagrange, who introduced the term derivative and the notation f prime of x. Then came Cauchy, who brought calculus into the form we use it today and defined derivatives in terms of limits. After him came Riemann, who gave us our modern definition of integrals via Riemann's sums. Calculus will forever continue to grow and evolve to match the necessities of the future. Thank you for watching a brief history of calculus.